so we are going to continue with our last three examples here on the last page. They have a little bit more going on. All right, so first let's identify the features of this graph. Since there's a 2 out in front of the cosine, my amp here is going to be 2. My period is going to be 2 pi over b. Here b is 3, since that is what's in front of the x. So my period is 2 pi over 3. There is no vertical shift since nothing is being added or subtracted. For my interval, we would have to calculate that. So I'm going to take everything that's inside the parentheses there. So 3x minus pi over 2 equals 0. And 3x minus pi over 2 equals 2 pi. All right, so here I would add pi over 2 to each side and divide by 3 to solve for x. So x is pi over 6. Here, when I add pi over 2, so 2 pi is the same as 4 pi over 2. And I would have to have a common denominator if I'm going to add those two fractions. So 4 pi over 2 plus pi over 2 would be 5 pi over 2. And then when we divide by 3, we get x equals 5 pi over 6. So my interval is pi over 6 to 5 pi over 6. So that's going to be my starting and my stopping location. For my guide, since it's cosine here, I know cosine starts and ends at its max and at its middle, halfway in between. All right, so this time, when I'm marking my scaling for the x-axis here, I don't have 0 and pi or 0 and 2 pi. I have pi over 6s. So what I want to actually do is make every 2 pi over 6. So I want to especially know where pi over 6 and 5 pi over 6 are then, because I know that's my stopping and my starting point. All right, for my y-axis here, I just have to make sure I can get up to 2 and down to negative 2 for my amp. All right, so now when I start, I'm going to start at pi over 6, and that's where I'm going to start at my maximum. And when I end at 5 pi over 6, I'd also be at my maximum. Halfway in between at my mid, and then at the zeros at the midpoints there. So now that I have the pattern, I can mark off the rest of my grid. And draw in my function. All right, let's look at another example that has a lot more going on. All right, so my amplitude here is the number out in front of sine, that's 3. My period is 2 pi over whatever x is being multiplied by. Here x is being multiplied by 2 pi. So 2 pi over 2 pi is 1. All right, there's still no vertical shift because there's nothing being added or subtracted. Let's calculate our interval off to the side here. So I'm going to take everything that's in parentheses. So 2 pi x plus 4 pi equals 0. So I would subtract 4 pi from each side, divide by 2 pi. So x is negative 2. All right, I would do the same thing and set equal to 2 pi. So I would have 2 pi x equals 2 pi minus 4 pi is negative 2 pi. So x equals negative 1. So my interval is from negative 2 to negative 1. All right. And now when I do my guide, this is sine. So sine's going to start and end at x-axis. Go up first and then down. All right, so now this time, when I'm doing my scaling, my interval is not in terms of pi. So I want to count by like 1s and 2s. And actually, since it's negative, I want to make sure I can see more of the negative portion of the x-axis. All right, so I'm going to make every 4 1 here on the x-axis. So negative 1, I'm starting at the x-axis, and my interval starts at 2 and ends at -1. Halfway in between, I'm back at the x-axis, and then up to my max, down to my min. All right, so once we have the pattern, I can continue to draw. Okay, so this is a very skinny graph. One last example here. So this time my amp is the number out in front of sine, so that would be 3. My period is 2 pi over my b. Here b is 2, so my period is just pi. Vertical shift, all right, so 2 is what's being added to this function since it's a positive 2. So my vertical shift is up 2. All right, my interval, to calculate that, I would have 2x minus pi equals 0. So that would be 2x equals pi, or x equals pi over 2. And then 2x minus pi equals 2 pi. So 2x equals 3 pi, or x equals 3 pi over 2. So that's my interval, pi over 2 to 3 pi over 2. All right, and my guide, I know this is sine. So I start and stop at my axis, go up and then down. All right. Since we have this vertical shift in here, this is where I'm going to take a different color, and I'm going to mark off where that vertical shift is. Since I know my whole graph is supposed to go up 2, I'm going to move my x-axis, so to speak, up 2. So I want to think about this dashed red line as my new x-axis. All right, and since we're in terms of pi over 2 here, I'm going to make every 4 pi over 2. So this would be 2 pi over 2 and 3 pi over 2. Since those are my stopping and starting points, I want to have those labeled. On the y-axis, we're going by 1. All right, so since I start at pi over 2, now I'm not going to be on the x-axis because of that vertical shift. I'm going to be up 2. Same thing at 3 pi over 2. You have to think about that dashed line as being your new 0 or your new x-axis. All right, so then since it's sine, I know in the middle I'm at 0. And now I'm going to go 3 above this x-axis for my amp and 3 below that dashed line. All right, so it's basically just like what we've been doing, except for that x-axis is, or that dashed line is like my new x-axis. So there's our function. Looks just like all the other graphs, except for it's been shifted up